Hello, my name is Diego, and today I'm gonna present my chess game project. So I'm gonna start with the chess piece file, which contains the functions of the base class chess piece. So I decided to create a chessboard pointer, which is gonna point to the board that the game is gonna initialize to. So all the pieces are gonna be related to that board that is gonna be created. Then we have a row and a column and a color. The color is just it's gonna be an enum to this is just to make my code more easier to read. Then I also have a constructor or default constructor, then a constructor which takes a pointer to a chessboard, then a color, which is gonna be the color of the piece. Then this is just assigning the values to my to my board and color. Then we also have our getters, setters for the row and the column. Then here I implemented this row valid, this column valid. This is just to check that we do not go out of bound. Then my string uh my string function, which is to get position, then also set position, and then we have our virtual functions right here, which is to string, which is just to convert, uh, which is basically to print the whatever, uh, whatever piece is on the board. Then also we have the legal moves, which returns a pointer to a vector of strings, and get player, which just gets the player, get the basically gets the piece what we wanna get. And then we can go ahead and start going to our chessboard. Okay, so here on my chessboard class, basically this is just the implementation of my code. Here I have my chessboard two string, which just brings the board every time I want. Like, let's say I make a move and then I have to print again the board. So this is gonna print again the board. This is basic. This is just like two for loops. Then if the board, so this basically means if if you go to A1 and you see that it's no pointer, that means that there is no piece there, so it's just gonna be then we're just gonna print a dot. Then if that's not true, then we're gonna print whatever piece is on that uh isn't that our like position. Then we have our constructor, I mean our initialize function, which just initialize the board to just a regular chessboard game. Here I decide to use a for loop for my pawns. Then for the other pieces I decide to actually like do it mine like by myself. So doing the like for example A1, H1, A8, H8, and so forth with the other one bishops, kings, queen, and knight. Then we have is empty. So basically, this is just like checking if the row and the call like if that at that position. So let at that position is there a piece at that position? If it's equal to null pointer, then we return true. Then we have place piece, which is our function that is gonna move the pieces. So we're gonna say if position is valid, then we're gonna say like okay, then which has by the way some arguments, and we're gonna say okay, row is gonna equal position dot get row index, which is position is another class from our which we implemented on our chess piece class. We also have column. Then we're gonna assign the column to position dot get column index of that object that like let's say we're gonna go to another place, then we're gonna pass that position here. we're gonna pass the position, and we're gonna assign those the row and the column to a new like to this new row and column. Then we're gonna say like, okay, if that chess piece is equal, we're gonna create that chess piece. We're gonna create an instant a pointer called existing piece, which is gonna be equal to that that piece that we wanna know. And then we're gonna say, okay, if that piece equals to null pointer, or if that piece get color, which is another function from our chess piece class. And then if that get color does not equal to get color, that means like if our existing piece is not the same as the at the same color, then we're gonna go here, and we're gonna say, okay, if existing piece equal does not equals null PTR, then we're gonna delete existing piece. Then we have for then if that doesn't happen, then we're gonna say, okay, that piece uh uh, so basically that piece is gonna equal to piece, and we're gonna say piece set position, and we're gonna pass the position we wanna go to, and return true. And if not, we're gonna return false because this is a bool. Then we also have has a pointing piece. Okay, so here we're gonna ask if the for example, here we have the arguments row, column, and color. So we're gonna return if the board is at the row, if the board at that position does not equals null pointer, and the board at that position does not equals the same color as our piece. Or basically what it means is if there is another piece of the same color, then we're gonna return true. Oh, we also have chess piece, which returns a pointer to a chess piece. I mean, get piece, which returns a pointer to a chess piece. And then we say if position is valid, which is position is valid is a function from our position class, and then we're gonna just assign values to it, and we're gonna return the piece at that indexing column. And if not, when we're gonna say we wanna say chess piece on the front and return null pointer. We also have the chessboard constructor, which basically just uh creates a chessboard with. Okay, so this is how it works. This is gonna create a chessboard that contains uh this is gonna be a bidimensional array, which basically shows the row and the column, and this is gonna, yeah, just that's just gonna create the board. Then we'll have our destructor to delete all of the memory that we allocated here, and this is the same thing. We're just gonna delete all the memory that we allocated. Then we have our move position, which we have from position and to position, where we want to move to where. And then, okay, so here these are part of my debugging code, so I know if I was messing up in something. But basically, this class just moved from one place to another place, and we just need to check every time we want to like move from certain position to another position. And here we're just gonna say like, okay, so vector, we're gonna create uh a pointer of moves, because a pointer to a vector of strings. And here, if you remember, legal moves was a function from our chess piece class, and basically this returns a pointer to a vector string, and we're gonna store those here, and we're gonna say, okay, the string to position to string, and we're gonna say move if move is legal is equal to false, and then we're gonna start like so basically here we have to check if the move that from we so if the move from where we want to go to the place we want to go. So basically, target is the place we want to go. And if they're both equal, then we're gonna say, okay, move is legal. I mean, move is true. Move is legal is true, and then we're gonna break. And then if move is legal, then we're gonna say, okay. from position get row index, and from position get column row index, and then we're gonna say that is gonna equal to null put tr because we want to remove the piece from that position, and then we're gonna say place, we're gonna call our other function to place that piece that we want to move to the other position, and we're gonna delete the moves because remember how to delete, and that's it. We also have our here is okay, so I'm gonna show my position class. Just a second. Okay, here. Alright, my position class is pretty straightforward. It's just like position class with row and with a row and column, and here is just setters, getters, and just bool functions that return if we're out of bound or if we're not out of bound. Then here from my derived classes, um basically what I did was for the pound for to create the toString, this was pretty straightforward. Basically, this is like a if statement. So if the color is equal to white, then we're gonna return this, and if not, then we're gonna return this. Then for the legal moves, we're gonna create a vector pointer, and then we're gonna okay, so we're gonna create a pointer to a vector of strings, and then we're gonna ask for memory, and we're gonna get a vector to string, which is gonna give us back a pointer. I mean a memory address. Then we're gonna say okay, direction star route. Okay, so direction here I try to set it up like where is the pound moving, we because it only has one direction, but since we have two, so the white and the black pounds, then we're gonna say okay, if the color is equal to white, that means that we have to go up, and if the color is then else, obviously if the color is not white, then we have to go down, and we have to start from position 6, and if it's white, we're gonna start from position 1, and uh then we just check for the standard one square move, which is when the just like one move, like one square move, basically. We check for bounds if the row plus the direction is valid, and then column is valid, and then if and also if the board is empty, and then we pass our our new position in the column, and if that's true, then we're gonna say okay, call the new call letter is gonna be equal to a plus the column, and here basically how it works is that we're using the ASCII values. So this is gonna add let's say 1 to a, then it's gonna be b, and so forth. Same thing with the row letter, and we're gonna do that, and then we're gonna push back our into our vector strings this move. And same thing with the initial two square move, just in this case it's gonna be +2 because that's a two square move. This is only gonna be if the row star equals to the star row. So if we're so this only applies when the pounds are on the let's say for white is 1 and then for black is 6, then that's only in those positions they can go 2 square. Well, they can only do 2 square move. Then the diagonal captures, this is just basically one up and then one to the right. So we're gonna say add one to the column and then add one to the row. And the same thing for if you wanna do it for the white pounds and the black pounds. And we're gonna return the moves. Then for the king, for the king I didn't implement. But I did for bishop. Okay, for bishop is gonna be the same thing. Just in this case, I store my movements in the bidimensional array. which is basically four moves because I know it has four moves. Either you go right, you go up right, up left, and down right, down left. So that's basically four moves. And then the two I decided to do two because you see you can iterate through the array and you can get like, okay, this is gonna be row, this is gonna be column, row, column, row, column. So we're just gonna iterate through the array while we're checking if the while we were checking if it's out of bound or if it's not. And if it's not, then we're gonna say, okay, if the board is empty at the new location, then if it's not, then we're gonna push back the new move. And if it is, then we're gonna check if it has a pointing piece, and we're gonna pass uh the new location we wanna go, and then if that's true, then we're gonna push back another move. Uh, rock the same thing is gonna be. Okay, so here I want to explain something real fast. Okay, so for this one, it's gonna be also the same thing with the rogue, but okay, so here what I did is, okay, so if I have a pawn in piece, we're gonna be checking, but uh, every time we pass the the for loop, we wanna increment the row offset and call offset, and this is because we're gonna check if we have more moves. So if we can move one more and one more and one more and one more and one more till we can till we go go out of boundary. Basically that's it. Also for the rogue, that's just the same thing. They only have four, which is up, down, right, left. And every time, for example, up, then it's gonna be one up, but zero to the left. Uh, Zero to the left, or right, and then that yeah, it's just up, down, right, or left. And then the same thing here. We're just gonna iterate through the array. We're gonna check, and we're gonna increment the row offset and call offset. Uh, and that's it. Let me see. Mm, Yep. Yeah, that's it. And then here on my main, I have I created a new chessboard, and then I started on a pointer. Then I initialize my board using the row operator. Then we're gonna do a while loop. So while the player doesn't say quit, then we're gonna keep this running. I mean, yeah. So basically here is like while the player has to select either Y or Q, and then if it selects Q, then we're gonna quit the game. Alright, so here um I started with this just position, which is gonna be the working when I prompt the user from so we're gonna say like, oh, select the piece to move, and then we're gonna store the call and the row, and then we're gonna create a position, and then we're gonna say, okay, chess piece, and we're gonna create a pointer of a chess piece, and then we're gonna say, okay, board and get piece at that position that we ask the user. Then we're gonna say, okay, then we're gonna store the moves of that piece. So we're gonna say, okay, piece get legal moves of that piece, and then we're gonna display those moves, and then we're gonna say, okay, then we're gonna say, okay, choose a move from the moves that we told you, and then we're gonna say, okay, position two, pause two. Then we're gonna do the same thing again, but now we're gonna move our piece. And we after we move the piece, we're gonna print again the chessboard, and we're gonna ask the player if he wanna quit or is still playing. Uh, and that's it. That will be all my project. Here's the chessboard one more time. Where is my position? Chessboard, queen, chess piece, position, knight, king, king, pawn, pound, chess piece, bishop, bishop, rook, rook, knight, and our mate. And that's it. Thank you so much for watching.